Hey guys, welcome back. Today we're going to be solving LeetCode 72, edit distance. Feel free to pause the video to read through the problems. I find the examples more descriptive. So given two words, word 1 and word 2, in this case horse and rorse. Okay, we want to find a way to convert the minimum number of operations. We want to find a way to convert word 1, horse, to word 2. And we're only allowed 3 operations: insert a character, delete a character, replace a character. So that being said, I hope the problem makes sense. I'm going to go ahead and move it to the notepad. So again, this problem is called the Levenshtine Distance, and I took the liberty of writing both word 1, horse, and word 2 down, also with the indices of each string. Okay, and again, only 3 actions: replace, delete, and insert. Okay, so the first thing, again, in this example, based on the LeetCode, we were told this guy's horse and rorse give an output of 3, so that's what we want to expect. So let's go ahead and see why this is and how this works. Okay, so the first step is to kind of like iterate through what we were given. So in the first case, our index, let me use a red for index. In the first case, we're on this index, okay? Index 0 for both words. Index 0 in word 1 is H, but in word 2 is R. So what do we want to do? There's obviously only one action we can do here when there's a mismatch. So step 1 is we'll replace. Okay, we'll replace what? We'll replace the H, because again we want to convert word 1 to word 2 with R. Okay, and once we do this, what does this result in? This results in the word RORSE. Okay, we've taken the first action. So next we move our index. Okay, I'm gonna move back to using gray. We move our index now to index 1, because we're on index 0. Okay, so 2, we're on O and O. They match. There's nothing to do, right? We want to convert O to O. There's nothing to do, so we just skip it. We keep moving on. We do absolutely nothing. Move on to the next guy. It's an R and an S. Okay, so in this case, there are 2 things we can do. The first one, which I'm going to call 2A, is we can replace. Remember, replace is one of the operations we're allowed to do. So we can replace this R in word 1 with the S to make it closer to word 2. In this case, here's what we're gonna get. Once we replace the R with the S, we're gonna get rose a request. Okay, that's the first thing we can do in step 2. But also there's something else we can do. We can realize that right after this S, right after this R in word 1 comes a S, so we can delete it. Okay, because we already have an S next. But we'll see how in the code. So the next step is just delete R. Okay, once we delete R, what does this look like? Again, keep in mind in step 2, A and B are mutually exclusive. We can't do both. We can only pick one. Okay, if we delete R, it's gonna look something like this, rows. Okay, again, we want the problem ask us for the minimum operations we need. Let's go back to the problem. We need the minimum number of operations. Okay, that's for step 2. Now step 3. Okay, so since 2 has A and B, 3 is also going to have A and B. So say step 3A, which is the case where we did step 2A, we replaced R with S. So in step 3A, what can we do? Okay, obviously we're going to move our pointer to the next guy, our iteration. Okay, so now we're out of word 2. However, we're still in word 1. So what do we want to do? Step 3A is we're going to delete the S in word 1. Okay, so this is going to lead us to keep in mind step 3A is a continuation of step 2. Okay, it's saying if we took the route of step 2A. So this is going to give us ROS. Okay, we deleted that S, so E is going to give us rows. But keep in mind we've already got rows as step 2 if we followed step 2B. But let's go on it. So step 3B, which is the case where we followed step 2B. Okay, what would we do? Okay, in this case, if we follow step 2B and deleted R, okay, keep in mind what we'll have left is rows, right? So we're going to be at E. So all we're just going to do is delete E. And then what output will we have? We're going to have ROS. This is exactly what we want. Okay, so you see, we want the minimum. So this leads us to 3, like we were expecting. Okay, so now let's put what we just did, let's put it into an algorithm and try to figure out what's going on. Okay, I'm going to draw a table. Okay, so in my table I'm going to have the first, this guy, as an empty string, and you'll see why it's an empty string in a second. Okay, I'm going to have this as an empty string and this as an empty string. Okay, then I'm going to write all the elements of word 2, not word 1, word 2. Okay, so what is word 2? Word 2 is R, O, and S. Okay, then I'm going to write word 1 next. Word 1 is H, O, R, S, E. Okay, let me go ahead and draw up my table completely, and I like the red. Okay, so yeah, we don't care about outside of this table, so ignore my terrible line drawing. Good, we have our table. Okay, so the first question to ask yourself in this table is, this is word 2, this is word 1. Okay, the rows represent word 1, the columns represent word 2. Again, this is the way to structure it. So ask yourself the problem: to go from an empty string, okay, to go from an empty string to an empty string, how many moves do you need to do? 0 operations. They're equal already, so 0. This is the number 0, not the letter O. Okay, now to go from an empty string to an R, what do you need to do? Simple, 1 operation, just insert R. Simple. So 1 operation. Okay, to go from an empty string, the row, to an RO, what do you need to do? Simple, 2 inserts. Insert R first, then insert O next. So this is 2. Again, by extension, it's going to be 3 here, because to go from an empty string to ROS, you need 3 insert operations. Insert R, insert O, insert S. Okay, that's good. So now we filled out the first row representing word 2. So now let's do the same thing for word 1. To go from an empty string to H, what do we want to do? 1, just insert H. To go from an empty string to HO, 2 inserts. Insert H, then insert O, 2. By extension, this is just going to be 3, 4, and 5. So now we fill these guys out. So now we have this. Let's figure out, to go from H to R, what do we want to do? Okay, to go from H to R, simple. Just replace H with R, so we know this is 1. But how do we get, is there a way, a formula to get this 1? Yes, there is, and I'm going to show you guys what the formula is. I'm going to draw a small 2x2 table here. Okay, so just a 2x2. Okay, and I'm going to call this number X. Okay, here's A, B, C. The order of A, B, C doesn't matter. X is simply represented by X is equal to 1 plus the minimum of A, B, C. Okay, calculate the minimum of A, B, C. That's what the value for X is. And simply in here, what I did was I said, what is the minimum of A, B, C? The minimum is obviously 0. Then added 1 to that, plus 1 gave me this guy. Okay, good. So that's how, so we go, to go from H to RO, what is the minimum of 1, 1, and 2? Minimum is simply 1. Add 1 to that, this is going to be 2. Okay, again in this case, to go from H to ROS, obviously the operations is replace H with R, that's operation 1, then insert O, insert S, which is 3, but again by the formula it says minimum of A, B, and C is 2, add 1 to that, so this will be 3. Okay, good. So now we're done with this row. So let's go into this next row. To go from HO to O, again this is the tricky part. If this, to go from HO, to go from HO to R, we already have this. To go from HO to R, okay, it's simple. Replace H with R and delete O, which is 2 operations again. But let's do with the formula. Minimum of A, B, C is 1, add 1 to that, 2. Okay, now it's O and O. This is a tricky situation where there's O and O. To go from HO to RO is simple. Just replace H with R, which is 1 operation. But in this case, if we take the minimum of this and add 1 to it, it's not going to work. That's going to give us 2. So in the case, okay, where word 1 of I equals word 2 of whatever index of J. Okay, if this case is equal, all we do is we just drag the previous guy down. So we just make this a 1. In the case where, in this case is O and O, we just make a copy of this guy. So in this case, we'll see how we do in the code. In this case, where word 1 of I equal word 2 of J, we just say this our matrix, if we call it dp of I, j, in this case, keep in mind this is a dynamic programming problem. It's just going to be equal to, okay, dp of I minus 1, j minus 1. Again, we're going to see it in the code, but let's keep going on. So the next guy, where O and S, they don't match, so we just take the minimum of these 3, which is 1, and add 1 to it, so this is going to be a 2. Okay, now what, R and R, again, similar situation, R and R matches. We just drag this guy down, so this just becomes a 2. Okay, next, R and O, okay, they don't match. We just take the minimum of this 3 ABC, which is 1, and we add 1 to it, so this becomes a 2. Okay, going on, and the next one, they don't match, so minimum of this is 1, this becomes a 2 also. So now we're at S. S and R don't match, so minimum of this is 2, add 1 to that, this becomes a 3, by extension this becomes a 3 also, this becomes, again in this case, S and S match. Tricky situation, right? What do? We just pull this guy back down, this becomes a 2. Now E, there's no E in this guy, so we just know what he's gonna be. This is gonna be 4, 4, and 3, right? With the minimum of A, B, C is 2, 2 plus 1 is 3, and this is the number we're looking for, 3. So that's how we have this value. Okay, so now let's put this to code. As always, we like to use Python. So I'm going to create my DP array, okay, and set him equal to zeros initially. Okay, so let's create his first the columns, right? The first row. Let's create the first row. 0 for I in range. What range are we looking for? Length of word 2 plus 1. Keep in mind why we're using word 2 is because, again, in our table, word 2 was our first row, right? He determined our column, but we're going the plus 1 is because we have an empty guy here to take care of the empty guy. Okay, so then let's replicate this guy how many times to get each of the rows. So we'll replicate this guy for j in range. What range do we want to go to? Obviously length word 1 plus 1. Again, the plus 1 is just to take care of the empty string. So now we're going to have a double for loop. So for, again, we're going to iterate for I in range. What range? Again, same length plus 1 to take care of the space like we talked of the empty guy like we talked about. Then we're going to duplicate this for loop and do it for j and word 2. Okay, now we have so now it's the meat and potatoes of the code. So we're going to say if I equals 0. Okay, I equals 0 meaning we're on the first row, right? So we're just going to say dp of I j, because we know I is 0, right? It's just j. This is simply the case where going through this table, okay, as we're going through, this is 0 index, it's 1 index, 2 index. You see how this is just 0, 1, 2, 3, right? I is just equal to j. And in case of I, 0 index, 1, 2, 3 is just equal to the number of indices, just simply like we wrote up here, right? Plus, again, we have the empty guy right here. Similar case in our elif statement. Elif j equal 0. Okay, dp of ij is just gonna be I. Okay, reverse. So this is straightforward. So now let's actually do some coding. So elif what? Now we want to take care of the diagonals, the cases where we had to pull him down where there's a match. Okay, and we do that by saying elif word 1 of I minus 1 equal, okay, word 2, okay, because I is controlling word 1, j is controlling word 2. Word 2 of j minus 1. What do we want to do? We just want to pull the previous guy. So dp of I j is just simply equal to dp. I'm just going to copy this because I'm lazy. Just simply equal to dp of I minus 1 j minus 1. Again, this is the case where they match, so we just pull in the previous index, pull in the previous guy, pull in the previous guy. That's what we're doing right now. Okay, now here's the final else. To be honest, we don't need the else, we could just put it up, but else. else. Okay, if none of these cases match, what do we want to do? Okay, dp of ij just equals, again, in our formula we said 1 plus the minimum of ABC, okay, where ABC is the surrounding guys. Okay, just 1 plus the minimum of what? A. Okay, this is A, this is B, and this is C. Then at the end, we just want to return the last guy, so we say return dp of -1, -1. Again, this is just returning this last guy right here. So this looks good. Let's go ahead and run code. Accepted. Let's go ahead and submit it. Bam. 36 percentile, not too bad. 42. So that's it for the video, guys. I hope it was helpful in showing you guys this really hard dynamic programming, and I'll see you in the next one.